In question 7, part 1, we have to prove the identity 1 plus cos upon 1 minus cos minus 1 minus cos upon 1 plus cos as 4 upon sin tan. Now, to prove any identity, it is easy if we start applying basic algebraic operations, and instead of writing cos theta, I'll just be using the letter C. So taking the LCM in part 1, from the left hand side, the LCM will be 1 minus cos and 1 plus cos. So this, when we take the LCM, 1 plus cos will multiply by, so this will multiply by 1 plus cos. So this will become 1 plus cos whole squared, minus 1 minus cos will multiply by 1 minus cos. So this will become 1 minus cos whole squared. Expanding 1 plus cos whole squared, we'll get 1 plus 2 cos plus cos squared minus. Now it is important to keep the brackets as the signs will change, as this negative sign is with the complete bracket. So this will become 1 minus 2 cos plus cos squared, and the denominator will remain 1 minus cos and 1 plus cos. Simplifying the numerator, we'll get 1 plus 2 cos plus cos squared minus 1 plus 2 cos minus cos squared. So the cos squared term will cancel, 1 minus 1 will cancel, and we'll get 4 cos upon 1 minus cos, 1 plus cos. Now we can write 1 minus cos, 1 plus cos as 1 minus cos squared. We will be using the identity x minus y and x plus y is equals to x squared minus y squared. Now we know that 1 minus cos squared is sine squared, so this can be written as 4 cos upon sine squared. Now to convert it to 4 upon sine tan, I can write sine squared as sine multiplied by sine. Now as sine upon cos is tan, so for cos upon sine, we will write tan in the denominator, and we already have sine, so this will be 4 tan theta sine theta. In part 2, we have to solve the equation sine multiplied by the term that we had to prove the identity, and this is equals to 3. So in part 2, it is sine multiplied by, now we had proved that this whole bracket is equals to 4 upon sine tan. So in place of this, we will replace it with 4 upon sine tan, and this is equals to 3. Sine and sine will cancel. So tan theta will be is equals to 4 upon 3. Now to find the value of theta, we will first find the basic angle, taking tan inverse of 4 upon 3. So tan inverse of 4 upon 3, if we substitute this in the calculator, we'll get 53.13. Now, as a basic angle is 53.13, we'll make this in the positive quadrants as tan is positive. So this will be A, C, T, and S. The basic angle will be made in the first quadrant. And so this is 53.13 and this is 53.1 in the third quadrant. Now to find the value of theta, the first angle will be anti-clockwise from the x-axis. So theta will be 53.1, as we have to give our answer to one decimal place for angles. And the second angle will be 180 plus 53.1, which is 233.1 degrees.